In this section, we will design and implement a scoring system to track player progress and achievements during gameplay. The system will dynamically calculate scores based on distance traveled, time bonuses, and coin collections. Additionally, we will include functionality to display the current score and high score on the UI, persist high scores across sessions, and provide feedback through sound effects. This scoring system will add depth and engagement to the game, rewarding players for their performance. We begin by creating a new canvas and setting its UI scale mode to scale with screen size. Adjust the reference resolution, setting the X value to 1000. Next, add 2 panels to the canvas and set their anchor preset to top right. Name one panel High Score Panel and the other Score Panel. Then position and size them appropriately on the screen. Inside the High Score panel, add a text UI element and name it High Score Text. Set its anchor preset to stretch, and adjust the margins by setting the left, top, and bottom values to 10 and the right value to 20. Similarly, add another text UI element as a child of the Score panel, name it Score Text, and configure its settings to match those of High Score Text. This will ensure consistent alignment and appearance for both panels. Modify the text by setting the font size to 40, aligning it to the right center, and adjusting the color as desired. The user interface canvas we're currently working with is intentionally basic for the purposes of this tutorial. However, it's important to remember that you have the flexibility to design and build your own custom canvas, incorporating additional UI elements to suit your specific needs and preferences. These elements can enhance the visual appeal and functionality of your game, providing players with important information, interactive controls, and an overall more engaging experience. For the time being, the existing settings on the current canvas will be sufficient to guide us through the tutorial and achieve the desired learning outcomes. First, we add a set of variables to manage the scoring and high score system. The player variable of type transform. Then, we add the score text and high score text variables, both of type text, which will display the current score and the high score on the UI. After that, we add the score multiplier, which is a float that determines how quickly the score increases as the player progresses. The time bonus interval and time bonus points variables are used to implement a periodic time-based bonus system, where points are awarded every specified interval. We include an audio source to handle sound effects, along with 2 audio clip variables: new high score clip, which plays when the player sets a new high score, and time bonus clip, which plays whenever the player earns a time-based bonus. 2 private variables are initialized for managing the actual score. Score, a float representing the player's current score, and last high score, an int used to store the previously recorded high score. The player controller variable is a reference to the player's controller. The new high score boolean tracks whether the player has achieved a new high score during the game. Finally, the high score file path string is used to store the file path for saving and retrieving the high score. Now we implement the start method. In this method, we first retrieve the audio source component attached to the same game object to handle audio feedback, such as playing sounds for high scores and time bonuses. Next, we set up the file path for storing the high score. The high score file path is constructed using Unity's application.persistentDataPath, which points to a location where persistent data can be saved. We combine this path with the file name endlessrunnerhighscore.txt. Then we set the reference to the player controller component. Next, we implement the load_highscore method to retrieve the saved high score from persistent storage. The method first checks if a high score file exists at the defined high score file path using file.exists. If the file is found, its content is read as a string using file.readAllText. The method then attempts to parse the string into an integer using int.tryParse. If the parsing is successful, the parsed value is stored in the last high score variable and returned as the current high score. If the parsing fails or the file doesn't exist, the method returns 0, indicating no high score is available. Then we go to the start method and set the high score text by loading the saved high score using the load_highscore method and setting its value in the high score text UI element. Finally, we start a coroutine, coroutine_timebonus_score, with the interval defined by the timebonus interval variable. This coroutine will manage the periodic awarding of time-based bonus points during the game. We will implement this coroutine next. This coroutine takes an interval as a parameter, representing the time in seconds between each bonus award. Inside the coroutine, a while loop continuously checks if the player is alive by referencing the isPlayerAlive property of the player controller. As long as the player is alive, the coroutine waits for the specified interval using wait for seconds. After the wait, the score variable is incremented by the value of time bonus points, awarding the player with additional points for surviving. Optionally, this is where visual effects could be implemented to enhance the experience. In this case, the code focuses on audio feedback, playing the time bonus clip using the play one-shot method of the audio source. This loop continues until the player is no longer alive, ensuring that bonuses are awarded consistently throughout the run. After that, we implement the update method to handle real-time score calculations and high score updates during gameplay. The method begins with a safeguard. If the player controller is not assigned or the player is no longer alive, the method returns early, ensuring no unnecessary calculations occur. The normal distance-based score is calculated by adding the product of time.delta_time and score multiplier to the current score. This mechanism ties the score to the player's survival time and progression. Additionally, the score multiplier is gradually increased by a small value with each frame, rewarding players with higher scores as they continue running. If the score is greater than 0, it is displayed in the score text UI element as an integer. The method then checks if a new high score has been achieved. If new high score is false, and the current score surpasses the previous high score, the new high score flag is set to true. At this point, the new high score clip is played to provide auditory feedback. Optionally, visual effects can also be added here to celebrate the achievement. We then implement the Save High Score method, which is responsible for saving the player's high score to persistent storage. It first checks if a new high score has been achieved. If true, the method writes the player's current score, rounded down to the nearest integer to the file specified by high score file path. The collect coin method provides functionality for adding points to the player's score when a coin is collected. It takes an integer parameter, coin score, representing the value of the collected coin. This value is added to the current score, dynamically increasing the player's total points. After that, we open the player controller script. We add a new public variable score of type score. We then amend the dead function by calling score.saveHighScore method. This ensures that we save the high score value for every run. After that, we go to the coin script. We add a new public variable score of type score. Then, in the start method, we locate the game object tagged as score, using gameObject.findGameObject with tag. Next, we retrieve the score component attached to this game object using getComponent and assign it to the local or class-level score variable. Then, we amend the collectCoin method to call score. Collect coin with the coin value as the parameter to increase the score. We then go to Unity Editor. From the scene hierarchy, we right-click and create a new empty game object, rename it to score. Reset the transform and drag and drop the score script component to it. Drag and drop the AJ game object to the player field of the score component. Then, drag and drop the high score text to the high score text field and score text to the score text field of the component. After that, go to the audio folder, choose the appropriate audio clips to assign to the time bonus clip and the new high score clip. We then select the AJ game object and assign the score script component to the player controller's score field. Select the score game object and add a new tag called score. Assign the score tag to the score game object. Then, add a new audio source component to the score game object. Click play and see the scoring of our endless runner. Once our player dies and the game restarts, observe the new high score text with the high score value. This concludes the section on creating a scoring system. In the final section, we will build a complete game level and discuss potential enhancements to improve the gameplay experience. Additionally, a bonus section includes a tutorial on procedurally generating game levels using scripting.